Now, in our previous video, we were interested in purely correlational relationships. But let's say that we're interested in answering that hypothesis that we began with, that's saying that something is predictive of another thing. When we use linear regression, basically we're regressing our dependent variable onto our independent variable. So the analogy I used in creating these variables, and again this is from a different data set, but I'm calling them different names for the purposes of this instructional video, is that the prediction was that people who have higher levels of numeric fluency would be more likely to have more positive attitudes toward learning statistics online. And so if I decide that this variable right here, which is something completely different, is going to represent my hypothetical variable, which is numeric literacy, and that this last variable will be attitudes toward learning online, I could run a linear regression. Now this is a very simple form of analysis, and oftentimes you'll end up looking at analysis that involves more than two variables when you're looking at regression. But for the purposes of this tutorial, we're going to look simply at these two variables. So if we go to regression under our Analyze tab, and then we select linear, we can put as our dependent variable this example variable, and I'm going to say this other variable, which again is not what it really actually represents, but for the purpose of this exercise I'm calling it numeric fluency, is going to be predictive. So we're regressing one variable onto the other. So we want all of this. If we're using more than one predictor in our model, let's say we have more than one independent variable, we'd be interested in the R-squared change, which will show you the amount of variance added by each additional variable. We want descriptives, and when we have multiple variables, this is when this becomes really important. We want collinearity diagnostics and part and partial correlations, as well as the ability to look at case-wise outliers, right? And so you can stick with outliers outside of 3 standard deviations as the baseline for what you want to inspect and possibly exclude from your analysis if they're exerting undue influence on your regression model. Okay, and so for our purposes, this is going to be simple enough considering how basic this particular type of analysis is, and we'll go ahead and run the analysis. So what should come as no surprise here, considering in our prior video we looked at the association between these two variables and we noticed that they were statistically significantly correlated between each other, that there was going to be a significant regression model, which is why I selected them again for the purposes of this instructional video. What we see here and what's important for us to know is basically these values. Our R-squared, which is basically a hypothetical it's saying that our variable, our independent variable, explains this amount of variation in the dependent variable. So an R-squared of 0.158 means that the independent variable explains 15.8% of the variation in the dependent variable. And then we also need to know our critical test statistics. So that has to do with our F statistic and also our p-values. And so our F statistic and its significance, which is a p-value smaller than 0.01, are statistically significant. And our degrees of freedom, 1 and 418 being the parenthetical degrees of freedom one would report with this regression output, shows that the F value, 78.245, and its subsequent p-value, which is smaller than 0.01, are statistically significant. And we know that this model with one variable as the predictor, entered as predictor, with the dependent variable regressed upon it, that variable accounts for roughly 16% of the variation in our dependent variable, right? And so here you get all your residual statistics and things of that nature if you want to go and explore individual values in terms of whether they are outside of the range that you consider to be acceptable for inclusion in your model. And as you add more variables to a regression model, you'll tend to find more and more outliers because obviously not all variables are going to act the same way. And so provided that they meet the standards that are required in terms of, inclusion in a regression model, both statistically and theoretically, you'll want to include them, but you'll also want to inspect where you may have outliers which may exert undue influence or potential suppressor effects, which are going to be beyond the scope of this basic tutorial.